In the previous video lecture, I mentioned the possibility that jet engines can be using the rocket equation. So let's investigate that. So let's say that we have a jet aircraft here. And so as the aircraft is moving along, so the aircraft is moving at 130 meters per second, relative to the air. So that's the airspeed. Okay. And what happens is that as it's moving along, that the engines are scooping up 81 kilograms per second of air. Okay. 3 kilograms per second of fuel is burned. So inside the jet engine here, okay, then we have air coming in, we got fuel mixing with it, it heats up, it burns, and it expands, because that's what's going to happen when you heat it. It expands, so it's going to exit at a much higher velocity than it went in. So it goes in at 130 meters per second, and then it exhausts at some other velocity right there. And so we're going to assume that this engine here, in order that the engine has, let's say the engine has 44 kilonewtons of thrust. So I want to know, what is this exhaust velocity? Okay. So we know that R exhaust equals the thrust. Okay. Well, the problem here is it's a little more complicated, because we have the dm dt going out times this exhaust velocity, but we have to include negative, but we have the plus dm dt of the air going in. That's actually a drag on the thing. Sucking the air in is adding mass to it. And so that turns out to be a little bit more complicated for us. And so what we're going to do is we're going to look at this and say, well, gosh, in that case, we're going to have to look at it and say this is a little bit more complicated. Okay, so what's going on? Well, first of all, the dm dt in is going to be 81 kilograms per second. The dm dt out is 84 kilograms per second. Well, why? Well, because we added 3 kilograms of fuel in there. Okay, so that means that the exhaust here. Okay, so what we're going to have to do is we are going to have to say the thrust of the engine has to be big enough to overcome, okay, the rest of it. So the thrust of the engine here is going to be the minus, dm dt going out, okay, out is exhaust velocity. And then the plus dm dt going in, okay, so that's the n times the v naught, okay, and so it has to be equal and opposite to all that. So equal and opposite means, minus here, and so we do a little bit of math here, and we say that dm dt out exhaust velocity equals Fr plus dm dt in, okay, and so the exhaust velocity is going to be the Fr plus dm dt in V naught, velocity of the aircraft relative to the air, divided by the dm dt out. that means the exhaust velocity is going to be equal to 4.4 times 10 to the 4 newtons plus 81 kilograms per second times 130 meters per second divided by 84 kilograms per second. So the exhaust velocity is 649 meters per second. Okay, and so you got to design it to do that. All right, so that is the application, this rocket equation to jet engines. So I don't remember if any of y'all were going into aeronautical engineering, but this would be an application of this rocket equation to another situation.